MS Ramaiah University of Applied Sciences.
Hi students, let us discuss on a simple open loop speed control of a DC motor. The aim of the experiment is to construct and conduct an experiment on a simple open loop speed control of a DC motor. The equipment required for this experiment are attenuator unit, servo amplifier, power supply, DC motor, loading unit, reduction gear tacho unit. Let us discuss about the theory behind this experiment. Speed control means intentional change of the drive speed to a value required for performing the specific work process. Speed control is a different concept from speed regulation where there is a natural change in speed due to change in load on the shaft. Speed control is either done manually by the operator or by means of some automatic control device maintaining the integrity of the specifications. The speed of three types of DC motors like series, shunt and compound motors can be varied by changing terminal voltage of the armature, external resistance in the armature circuit and flux per pole. The first two cases involve change that affects armature circuit and the third one involves the change in magnetic field. Therefore, speed control of DC motor is classified as armature control methods and field control methods. In this experiment, we are using armature control method to control the speed in which current flowing through the armature is controlled by power amplifiers. The limitation of this experiment is this is not suitable for variable loads. The connection diagram is as shown. After completing the experiment, the characteristics what we will get from this experiment will be like this. The preliminary procedure which is required for this experiment before connecting the wires is attach the AU150B, SCA150D and PS150E to the base plate by means of the magnetic bases. Fit the eddy current brake disc to the motor shaft as shown. Now attach the DCM150F to the base plate by means of the magnetic fixings and fix the plug into the SCA150D. Attach the GT150X to the base plate by means of the magnetic fixings and position it so that it is connected to the motor shaft by means of the flexible coupling as shown. Attach the LU150L to the base plate by means of the magnetic fixings and position it so that when the cursor icon position 10, the eddy current disc lies midway in the gap with its edge flush with the back of the magnet. Fix the plug from the SCA150D into the PS150E. Connect the power supply to the main supply line. Do not switch on it. The procedure of the conducting experiment is first connections are made as shown in the diagram, then switch on and turn the potentiometer knob. This will start the motor rotating for some reasonable speed. Use the voltmeter to measure firstly the amplifier input voltage relative to 0 volts and secondly the tacho generator voltage at socket 2 with socket 1 connected to 0 volt on GT150X. The ratio of tacho generator volts per input volts represent the speed constant or the speed gain of the motor amplifier. It is an important quantity in determining the servo performance. As the motor accelerates, the armature generates an increasing back EMF VA tending to oppose the driving voltage Vin. The armature current is thus roughly proportional to VA. If the speed drops, that is due to loading, VA reduces, the current increases and thus so does the motor torque. This tends to oppose the speed drop. This mode of control is called armature control and gives a speed proportional to Vin as shown. Set the magnetic brake to the unloaded position and turn the potentiometer till there is a reading of 1 volt on the voltmeter. Record the speed. Repeat this reading with a 2 volts generator output. Then repeat for 3 volts, 4 volts and 5 volts. The procedure to plot torque versus speed characteristics. To measure the torque versus speed characteristics, fix the brake so that it passes over the disc smoothly while the motor is running. Set the brake at position 0 and increase the input voltage until the motor rotates at close to its maximum speed. Then set the brake at position 10 and if necessary reduce the input voltage so that the ammeter on the PS150E is just below 2 amps. Note the value of the input voltage. Take tachogenerator readings over the range of breakdown to 0 position. Now reset the brake back to maximum position and reduce the signal input voltage so that the motor is slowly rotating, and note the actual value of the input voltage. Repeat the above steps for different readings.
Hi students, the name of the experiment is open loop speed control of DC motor. Before introducing you into control systems lab, we want to discuss what is control system and their types. The control system is a system which has an input and an output, where input is the physical change or the variable which is to be controlled, and the output will be the physical change or the variable which is controlled. So there are two types of control systems. One is open loop control system and another is closed loop control system. In these two control systems, we are discussing the open loop control system for the DC motor speed. So here we want to control the speed of DC motor. So here there are two important things. One is the desired output and the actual output. Actually, the desired output is actually what we want. What I can say, the set point or the actual actual output what we want. And the actual output is the output state what we are getting from the control system. In open loop, there is no feedback from the output to the input. And another type is the closed loop control system, in which we can see the feedback. So if you are doing an experiment on closed loop control system for the DC motor speed, then we will identify and we can see how the feedback works and how we are able to get the desired output. The apparatus required for this experiment are the power supply. As you can see in the front panel, this has a power on off switch and then an ammeter to read the current, and then two sets of plus or minus 15 volts DC supply. This is one, this has plus 15 and then the ground and then the minus 15, and this is another one, this is plus 15 terminal and this is ground and then this is minus 15 terminal. And then it also has two sets of AC supplies here. One is this one and another is this one. Here this one will give 18 VAC 1 ampere of supply, and this gives 9 VAC 10 milliamperes of supply. And then the servo amplifier, this is the servo amplifier unit. This has transistors to drive the motor in either direction, and this also allows the feedback, hence the name servo. As you can see, there are two inputs to give the feedback, and then this has the terminals to connect the supply also. As you can see, this is the plus 15 volts and this is minus 15 volts terminal and this is 0 volt terminal. This unit also has the terminals to monitor the voltage and then another terminal to monitor the current. Another important one is this has a multi-way connector which is of 12 point. And then the DC motor, this is the DC motor unit. This unit contains a DC permanent magnet motor which has an extended shaft and onto which can be fixed the magnetic brake or inertia disc. The shaft extension, this shaft extension which is supplied unassembled, usually this will be unassembled, it's already assembled here, should be fitted to the motor shaft and secured by the two 1.5 mm These are 1.5 mm Allen screws. It may be left permanently fitted like this. And then this is the reduction gear tacho unit. This contains a speed reduction gearbox with a ratio of 30:1 from the high speed input shaft to the low speed output shaft. As you can see, it has 4 terminals on the front panel to give the supply of plus or minus 15 volts. And then it has other 2 terminals like tacho RPM and then DC volts. The tacho RPM terminal is used to measure the tacho speed, and this terminal DC volts is used to measure the voltage. This switch switches between the tacho RPM terminal and then the DC volts terminal. These are other 4 terminals. These are used to give the tacho generator output to other sections of the control system. And another important part in this unit is the display. This is used to see or to monitor the tacho speed as well as the DC voltage required to achieve that tacho speed. And then the loading unit, this has the magnet. When this magnet comes near the aluminum disc, or what I can say the inertia disc, which is connected to the DC motor, when it is rotating, the eddy currents are induced, or I can say the generates in this, so that we can see the effect of brake. And then attenuator. This unit contains 2 variable 10 kilo ohm potentiometers. As you can see here, these 2 knobs are actually graduated from 0 to 10. So what we can do, we can vary the resistance till 10k, and then the different resistance values can be taken by using these 2 sets of terminals here. Then we also require the connecting wires or probes, and these are the connecting wires. These are used to do the experimental setup to connect between different units of the system. Let us start the experimental setup. Before connecting, we shall arrange all the units properly so that we can connect them easily. Another important thing is every unit has a magnetic plate so that we can fit these units onto the iron platform easily. This is the servo amplifier unit. I'm fitting this here. You can see here, you can move these units like this. This is another advantage. This is the power supply. I'll place it here. So better if we place these 2 nearby, so that connections will be simple. And then this is the motor. I'll place it here. And this is the reduction gear tacho unit. Here, while placing this, we have to take care, because using hexagon couple, I have to couple this. I have to couple like this. Already we have another hexagon couple here, so that I can fit this easily. You can see here how I am fitting this. So I'll move this a little bit. This is how we will fit the reduction gear tacho unit. And if I rotate it, this has to rotate. That's another important thing. This is easily fitted to the shaft. If I rotate this, this should be rotated. Yes, this is somehow we managed to do that. Yeah, this is right. And then this is the attenuator unit. I can place this one in between anywhere here. And then this is the loading unit, so I'll put it here. So loading unit should be like this. It should be close to the aluminum disc or the inertia disc. After arranging the units, now let us start the connections. First, we shall connect the servo amplifier to the power supply using this multi-way connector like this. It should be properly fitted. Yeah. After connecting servo amplifier to the power supply, I've connect DC motor to the servo amplifier using multi-way connector. Like this. This should be properly fitted. Now I'll take the connecting wire and connect these wires between the power supply and the reduction gate tacho unit. You can see here, this is red wire. This red wire will go to the plus 15 volts. This is the red indicating terminal. You can see here, this is red, and then here this is a block. I'll connect this block. This is to ground block wire, and this is the blue wire. I'll connect this to the minus 15, and then other ends will go to this red wire has to go to the plus 15 only. They should not be interchanged. And then this is the ground block wire, and then this is the blue wire. And then another important one is attenuator unit. I have to connect attenuator. Before that, I have to give the input from the attenuator to the servo amplifier as input. So this is very important, so as to drive the motor. Now what I will do, I'll give the supply. I'll take the supply to the attenuator from the servo amplifier only. This red wire I'll connect here. This plus 15 only I'll take, and then I'll take this black wire and I'll connect that to the 0. And then this red wire will go to red connector. This will go to this end of the attenuator port, and then I'll use this 0. What I'm doing, I'm using plus 15 and then the ground. So I can vary the voltage between 0 to the plus 15 volts. Now I'll connect this black wire to here. Now we have completed the connection between the attenuator unit and the servo amplifier. The very important one is I have to take the output of attenuator here. From here I'll connect the wire to the input of servo amplifier. So now what happens when I give the input, when I vary this knob, when I change the resistances, the voltage will be allowed, the current will be allowed to enter into the servo amplifier, so that the servo amplifier, what it will do, it will drive the motor through this multi-way connector. So the motor will start running. That's the idea behind these connections. Next, another important one is I have to connect the tacho generator output. This is the tacho generator output to the tacho RPM, so I can see the output directly from I can see the output on the display directly. And another one is to read the voltage also. Now what I will do, I'll connect from here to here to read the voltage. This works as the voltmeter and this works as the tachometer to indicate the speed. And then I'll take another connecting wire. I'll connect from 0 to this one, the first terminal of the tacho. This completes the connections of this experimental setup. Now let's start the experiment. Before starting the experiment, the knobs of the potentiometer should be kept at 0, and then I'll switch on the power supply. Then the power off switch will be switched on. Now you can see the reading of the tacho generator. Now it's showing 0. Now the switch position is at tacho RPM. Now the tacho RPM is 0 because the motor is not running. You can see the motor is not running here. Even the voltages, you can see the voltage is exactly 0. Now what I will do, to start the experiment, I'll start with by giving the input. The input is given to the servo amplifier through the attenuator using this pot knob. Now the pot knob is at 0. Now what I will do, I'll just increase this. Now you can see how the motor speed is increasing. The motor is start running and you can see the speed is increasing. You can see now the RPM is about 1100 RPM, and then I can also measure the voltage what we are giving to this. Now the voltage what here given is 3.1 volts. For 3.1 volts we are getting 1100 RPM. What I will do, I'll increase further. I'll increase the voltage. You can see here for 3.8 volts what I'm getting, the RPM is around 1360, and then further I'll increase this. Now I'll change the voltage to 4.3 and I'll record the RPM. Now the RPM is increasing. Now it's around 1560. What we are actually identifying, or what we are actually monitoring here, the important thing is, as the voltage increases, the speed of the motor is also increasing. What we can see, there is linearity between the voltage what we are giving here and then the speed of the motor. What happens here, when I increase the voltage, the current flowing through the armature increases so that the motor starts rotating at higher speed as I increase the voltage. This is a simple armature control, I can say. This is a simple armature control, and this is also an open loop control system. You also know, you can see here we have not taken any feedback from the output of the motor to the input of the servo amplifier. So there is no feedback in the system. So this is considered as open loop control system. Another important one is not only plotting the voltage versus the speed here. What you observed here is how we can control the speed of the motor just by varying the voltage, and also by changing the load. That's another important one. I can plot this torque versus speed characteristics also. Now what I will do, I'll start with the loading unit. Here you can see the loading unit. Now it is at exactly, the pointer is located at 0. Located at 0 is the pointer where I can easily move this magnet towards the aluminum disc like this. You can see the markings here. Now I'll keep this to 5. Just I kept this as to 5. Now what happens? I'll see the voltage. Now the voltage is what I'm getting is around 2.97 volts for 2. I'll put this voltage to 3. What I'll do, this is 3, exactly 3.15. Okay, it's nearer to 3. So the RPM what I'm getting is around 1120 and 130. Now what I will do, I'll increase this. What I'll do, I'll just move this magnet towards the disc like this till 10. Now you can see the speed should reduce. It's around 1120. Now what I will do, I'll move this towards, I'll keep this, I'll move this back to 0, and I'll start moving towards this. Then what I will do, I'll start with 0 and I'll move like this. So this is very important thing, they should not touch the disc. You can see here, now it is exactly at 5. Now you can record the speed. The speed is reducing. This is quite interesting. This is around 1060. What I am doing here, I am moving this magnet nearer to the disc. What happens when I move like this? What happens? Automatically, due to eddy currents generated, there is braking effect. This is another important thing. So the speed is getting reduced. Even using these things, I can plot the speed and torque characteristics also. This completes the experiment. This is all about open loop control system for speed control of DC motor. Thank you.
At MSR UAS, we spark your imagination unlike any other.